Alright, we're going to look at graphing rational functions such as y equals 9x plus 1 all over 3x minus 2, and of course we're looking to do this without a calculator. So in order to help us graph this as accurately as possible, we want to find out as much about this function as we can. So in any particular order here, it really doesn't matter the order, how about we find our vertical asymptote? Well, recall this is where we are going to set our denominator equal to 0. If I do that, I'm going to get x equals 2/3. So I'm going to go over here to my graph and I'm going to approximate where 2/3 is. Okay, so I'm going to draw myself a dotted line and I'm going to label this x equals 2/3, and that is where my VA is. So VA at x equals 2/3. Next, how about we tackle the HA? Well, notice we have equal powers here, and 9x and 3x. So that's going to be the ratio of the coefficients. So we're going to have y equals 9 over 3, which is just 3. So up here at y equals 3, we're going to have a horizontal boundary line. So here is our HA at y equals 3. Alright, we still haven't drawn the actual graph yet. All we've drawn so far are the two asymptote lines that we know are going to bound this graph. Alright, so what we need to do now is consider the intercepts. Okay, let's find our x and our y intercepts. So to find my x-intercept, I know that I'm going to put a 0 in for y. And to find a y-intercept, I know I'm going to put a 0 in for x. So let's find our x-intercept. To find an x-intercept, we're going to put a 0 in for y, we said. So we're going to have 0 equals 9x plus 1 all over 3x minus 2. Well, if we put this over 1 and cross multiply, you end up with 0 is equal to the top, and that is going to give me x equals negative 1 over 9. So at negative 1 over 9, so just a smidgen here to the left of the origin, we know it's going to pass through that point. And now let's find our y-intercept. So we found the x-intercept. Now let's find the y-intercept. The y-intercept occurs when x is 0. So I'm going to plug a 0 in where I see an x. And that is going to give me negative 1/2 for the y-intercept. So negative 1/2 for the y-intercept would be down there. Well, that gives us a pretty good idea of what's going to happen. Remember, we know that these asymptote lines are boundary lines. So it's going to be bounded by those dotted lines. Okay. And then there is another section of the graph that we're missing. What we want to do is do a test point. Okay. So if we look at this region of the graph up here or over here, we don't know if the function is in this bottom one or if it's in this top one. So let's do a test point to see where it is. Let me get rid of these arrows, or these stars. So let's do a test point. So what if we were to plug in 2? Okay. So if I were to test x equals 2, just to see what we get for our point, we'd have y equals 9 times 2 plus 1 all over 3 times 2 minus 2. That would give me a y value of, let's see, it's 18 plus 1, so that's 19 over, we'd have 6 take away 2, so that's 4. And if we're trying to approximate what that is, we know that 20 divided by 4 is 5. So this is a little less than 5, so that tells us that on our graph, when x is 2, the y value is going to be a little less than 5, so we know it's going to pass through this point approximately. Okay, and so that's enough to tell us that it's going to be bounded by this section up above. It's not going to be down below that line. It won't be in this region right there. Okay, we know it's going to be above where that point is. Okay, so with these rational functions, okay, it's important to understand that each asymptote gets used 2 times. So notice how the HA is being used over here, and then over here, and then the VA is being used. It's being approached 2 times by the function as well. Okay, so the boundary lines get used 2 times. Okay, so on the extreme ends of our functions. So what do we do here to recap? We found the VA, we found the HA, we found our intercepts. To find an x-intercept, put a 0 in for y. To find a y-intercept, put a 0 in for x. And then you may want to plug in and find a point or two, okay, which we're calling a test point, to just get a feel for where the curve is going to be passing through. Okay, so that is your process for graphing these functions.